Good evening, everybody. Today we intend to discuss on induction furnace, which is the main work cum production center in a steel plant. Induction furnace and its management. Amit Mukhopadhyay, induction furnace melting professional. Induction furnace in an SS or MS shop is most vital station to make a mark in the organization ROI, return on investment. It's a production come work center, so its importance in the context of timings, along with specific power consumption, refractory consumption come live, and above all, safe working practices are the today's subject of discussion. Induction furnace and its technicalities. The shape, size, and material specification of the induction coil are one of the most important areas in attaining the performance of induction furnace. The transfer of heat from the coil to the metal occurs through electromagnetic induction, conduction, and convection. IF rate of heating or rate of melting depends on various factors like coil design, power input, scrap density, and quality and rate of feeding, besides of porosity in the charged materials. One of the crucial factors to manage the IF efficiency is regular maintenance, coil cleaning internally and externally, and a vigilant eye on if anything goes wrong. Let's try to find out a realistic example of melt rate for a medium frequency IF, capacity of 25 metric ton with 7,000 kilowatt input power. The calculations are self-explanatory. So, with a power input of 7,000 kilowatt, the estimated rate of melting is approximately 793 kg per minute. But please note that it's far different than actual rate of melting because of it is a simplified calculation and actual melting rates may vary depending on factors like furnace design, metal composition, and specific operating conditions. Kindly keep in mind that this calculation is an estimate and may not reflect the actual performance of a specific induction furnace. Induction furnace can have sponge iron or threaded and HMS or recycled SS scrap or turnings depending upon the geographical location, business strategies, sales segment, etc. We are supposed to understand that every type of scrap mix and necessary preventive actions so that the timings and power consumption can be optimized. When scrap mix is sponge iron along with pig iron. Number one, preheating. Preheat the furnace to 1000 to 1100 degrees C before charging. DRI to reduce melting time. People have tried to keep hot heel in bigger size furnace and experienced significant good results. Number two, charge quantity. Calculate the desired DRI charge weight based on the furnace capacity and desired melt rate. Number three, input power. Power should be 700 to 900 kilowatt per metric ton to attain a smooth rate of melting. Number four, control, monitor, and control the temperature to avoid overheating and oxidation followed by metal losses. Number five, in sponge iron melting, it is essential to remove the slag time to time so that further melting can be expedited. We need to make a continuous monitoring system in sponge iron of iron metallic and FET iron total besides of phosphorus checking in case it is an MS or carbon alloy producing shop. When scrap mix is ready, check and ensure the uniformity in scrap sizes, cleanliness, and dryness to attain a good melting. Preheat the furnace to 900 to 1000 degrees C before charging shredded scrap. It will facilitate the melting process. Number three, power input. Apply 500 to 700 kilowatt per metric ton as input power to attain a smooth melting. Number four, monitor and control the temperature within desired ranges to avoid overheating and oxidation metal losses. When scrap mix is SS scrap or turning. Number one, scrap preparation is first and foremost step to start with uniformity in size and shape, cleanliness and dryness to follow for efficient melting process. Number two, charge weight needs to calculate based on furnace capacity and the desired melt rate. Number three, implement a stepwise heating rate. Initial heating 0 to 30 minutes, 50 to 60% power input to avoid overheating. Medium heating 30 to 60 minutes, 70 to 80% power input for steady melting. Final heating, rest time 90 to 100% power input for complete melting. Number four, monitor and control temperature to avoid overheating and oxidation metal losses. Number 5, regular monitor and melting process and adjust the parameter as needed to optimize the timing. Common strategies in reduction of melting time: furnace idle time reduction, continuous monitoring, energy efficient furnace design, advanced control system. Always brainstorm about further improvement. Refractory selection and optimization of the refractory consumption with thoughtful decisions. Quartzite lining mass: an equal mix in the granulometry of the quartzite, proper installation with high purity quartzite and low impurities and strictly moisture free. Adequate cooling in the copper coils. Regular maintenance. Controlled furnace operation with proper temperature management planning. Any raw material which can form slag should be avoided. Because of what? Because of that, slag can make a barrier in smooth melting process. Neutral diamond mass. The aforesaid recommendations will be the same. Listen to your supplier who understands better refractory than you. Scrap quality monitoring and conditioning as per requirement. Analysis of poor performance through systematic scientific approaches. As a production come work center, the induction furnace should be monitored in careful manner. The timings, the specific power consumption, the rate of melting, the load factor, along with visualization of the operating parameters like frequencies, voltage rate of erosion, thermal shock, etc. In NRM, it's the spinel bond which forms in high temperature end. Let's consider that when you are operating with a brand new lining or sidewall patching, the hot phase will get centered. As a consequence, when we hold the metal temperature with 1650 to 1680 degrees C. But in SS, the working temperature is much less, so it's advisable that with an average erosion rate after 15 to 20 hits, holding at the high temperature end will be recommended for the sake of spinel formation to obtain a better lives. Kindly remember the average lining thicknesses may vary based on erosion of the refractory. Thermal discipline, working temperature in case skull is getting charged, then we must become careful about the embedded slag. The embedded slag can become deleterious in excess refractory erosion based on the compositional aspects and on the nature of the slag. In quartzite lining, which is a cheaper version of the lining mass, but it's not suitable for SS melting because of so many limitations in the composition. A controlled temperature working can be helpful in obtaining a better life besides of pre-decided cares in before lining and during lining installation. Cleaning up the floor, check all electrical, mechanical, and water connections. All forking tools should be in the proper condition. Coil coat surface should be smooth. No carbon deposition, no big cracks, pockets, and looseness. Coil coat thicknesses should be 22 to 25 mm. There are enough care slide with either quartzite or NRM, but we must follow some common methodology to optimize the refractory consumption followed by lining or patching life. Monitor temperature and chemical specification and control condition based on the preventive action on excessive wear of the lining masses. Avoid overcharging, which can lead to excess lining wear. Use appropriate launder design to minimize lining erosion. Avoid sudden changes in furnace operation. Besides of melt rate, power consumption and cares on refractory masses, we must be careful about safe working practices. It's melting pot and people comment that garbage in and garbage out. Please remember, in smaller setup, induction furnace is always advisable in comparison to EAF because of multiple reasons. This platform is not well to do to discuss on the said comparisons. We will only discuss the safe working for the human safety, machine safety, material safety, and above all, the safety of the organization. Never charge any closed piece in the induction furnace, whether it is SS or MS. It can cause severe volume expansion of the entrapped air and upon heating finally blast due to overexpansion. So it's a must. We should check, monitor the scrap on the platform before putting in. It can really cause severe accidents. The small diameter pipes are risky to charge in the furnace once it is in semi-melt or melted state. But again, the entrapped air, once get heated up, can throw semi-melt or melted metal through escaping of air from the pipes. If it is bundled scrap, then avoid to charge on melted bath, and in case closed pipes, closed pieces, valves, heat exchangers can burst due to entrapped water, oil, inflammable objects. It is always advisable to take preventive actions. With fine sponge iron, there can be ample chances of eruption or boiling because of less permeability within charge, followed by no passage to escape the generated gases during melting. With very low FEM and FET, especially in pallet sponges, a susceptibility of eruption boiling due to the differences of FEM and FET. Iron sponge is always preferred, at least in the context of accidents, may not be in the context of cost. Selection of charge material is an art, and charge quantity optimization do have certain methodology. So long story short, it is not garbage in and garbage out. There are enough material science and refractory engineering are relevant on the shortcomings. Oily and scrap mixed with dirt in shredded can create quality issues due to slag and hydrogen entrapment and emission. Hope the aforesaid in-hand experiences can be helpful to the MS Carbon Alloy Steel SS any other makers on drawing a good conclusion. I shall definitely envisage the bigger issues relevant to induction furnace, productivity, melt rate, refractory consumption, safe working practices, betterment on every aspect of the operation and maintenance planning, preventive maintenance, etc. in the near future with broad spectrum and through better clarity. Thank you very much for your time and patience to listen. If you have any questions, kindly ask in comment section.